Okay, so in this lecture we are going to focus on file system navigation. So our previous program only executes command on the victim machine. So if we want to navigate through the file system, we cannot do this on our regular program because the execute.command function, which is a part of Go standard library, does not support this functionality. So what we have to do is that we have to write a new package which would be called move, and then this package will provide us functionality of navigating the file system. So see you in next lecture. Okay, welcome back everyone. So now our goal is to use file system navigation, or to do file system navigation. So now the first goal should be to create a new package. So let's create a new package called move. So what we want to do is that we want to use this move package and then use this to navigate through the file system on our victim machine. So let's create a new file. Oops. File, and let's call it move. Okay, and then we will create a function called navigate file system. Okay, and this function will take on connection, which would be of type net.conf, and then it will return an error of type error return. So now we have the basic functionality of our function set. Now let's go to the main function, and then we need to add another case which would be for navigating file system. So I'm going to call it case user input, and then we will set the condition to 2. So if we press 2, we will enter the file navigation menu. So let's print the statement here, and let's call it println, and let's say file system navigation. Okay, so now here we will call this navigate file system function. So let's call it navigate file system, and then it requires connection, returns an error, and then we are simply going to display this error. So now we have this main file set up. The next goal would be to define functionality of this function, which we will do in our next lecture. Okay, so now let's start developing this navigate file system function. So the first thing we need to do is we need to send the present location to the server. So we can get the present location by using os.getWorkingDirectory method. So this method will return our present working directory and error if there is an error. So it will return two arguments. So I'm going to store the first one is pwd, or present working directory, and then the error. Okay, so let's just print it for the sake of understanding, and then let's handle the error as well. If error is not equal to nil, we can say that cannot get, don't get present directory. Okay, if we have a proper working directory, what we need to do is we need to send this through this connection to our hacker machine. So let's say we want to, actually before sending it, we need to append a \n character to this present working directory, so we are able to read it properly on our server machine. So let's say pwd raw equals to pwd plus \n. So now what it will do is it will return the present working directory, and it will append a new line character to it. And now we can simply send this by using connection.write method. dot write and then pwd raw, and then it will return the number of bytes that it wrote and error if there is an error. So I'm simply going to print out a statement fmt.println that, okay, so let's say I will say number of byte, so I can display that how many bytes were written, so I can say dash number of bytes were written. Okay, so now we have sent the present working directory to our server machine. So in next lecture we will proceed further. So let's move over to the Linux machine. So the first step is to create a move package. So I'm using the same naming convention as I used in Windows. So I'm going to call this as move, and then I'm going to create a new file. Let's call this mv. Okay, so now we will create the same function here called file navigate file system. Get file system, and then it's going to receive connection of type net.con, and then it's going to return an error of type error, and then return. So now you have the base structure for this function complete. Now let's go to the main function and create another case. So I'm going to call it case user input equals 2. So if a user presses 2, we move over to this thing. So fmt, let's just print a statement called navigating file system on victim, and then we are going to call this function. So I'm going to call it navigate file system. It's going to receive a connection object, it's going to return an error, and then simply I'm going to display this error. So now you have this thing complete. Now the next step is to develop functionality for this function. So as you already know that we are initially sending a present working directory from our Windows machine, so we need to receive the present working directory using this connection. Okay, so the first object is to create a new connection reader. So I'm going to call it connection reader, and then I'm going to use buffer input.new reader, and then I'm going to pass the connection. Okay, once I have this, I can simply read this connection reader dot read string. So I'm sending the present working directory from my victim machine, and then I'm receiving the same here. So I have to store it in a variable. So let's use \n as a delimiter, and then I'm going to store it in a variable. I'm going to call this variable as initial pwd raw, since raw refers to those values that contains \n at the end. So I have developed this naming convention to easily understand what is happening, and then it's going to return an error. Alright, so let's create a new variable called initial pwd, and then remove the \n from this variable. So it's going to be strings dot trim suffix initial pwd, and we have to remove \n from this variable. So now we have just the present working directory. Now the next step is simply to print this. So I'm going to use fmt.println. So what I want to do is initial working directory. So I'm going to use print function instead of println, so not raw, so it should be pwd. So now my goal is to write a program that will look something like this. For example, it will tell us what is the working directory. For example, c \windows something \go. I'm just giving an example, \source, and then whatever our working directories, and then these two greater than signs. So this whole statement will look something like this, and then we can write our commands here, for example cd move or something. So this makes intuitive sense. Okay, so that's it for this lecture. See you next. Okay, so our next step is fairly simple. We just have to get the user command, which would be of type cd space something, for example move up or down the directory. And then once we have this command, we just have to send it to the victim machine to run this command on the victim machine. So in this lecture we are going to focus on getting the command from the user. So to get the input, we have to define stand command reader. So I'm going to define command reader. So this will read command from the standard input. It should be of type buffer input output dot new reader and then os.stdin. So now we have a reader that we can use to get the user input. So to simply get the input, we have to use the command reader dot read string and then \n. This will return us our user command. The user command would be of type user command, and then we are going to call it raw since it contains \n included. Once we have this command, let's just check for an error. Fmt.println, you can say that unable to read command. Okay, our next step is to send this using the connection. So I'm going to call connection.write and then simply send this command as it is. Byte user command raw. Now we are sending the command and then just check if the command is written properly or not. So println, so we can say that n bytes were sent to the victim machine. Note that I'm using all these write statements or print statements just to make it better to understand and debug the code. You can skip these. Okay, so that's it for this lecture. In this lecture we got the user input and then sent the user input to our victim machine. Okay, so let's move over to the Windows machine, and now we are going to read the command that we sent from our server. Let's create a connection reader or command reader. So buffer input output dot new reader, and then I'm going to give the connection as the input since we want to read from the connection. The next step is to read the string. So I'm going to call command reader dot read string and then the delimiter, which is \n, and then I'm going to store it as user command raw error. And then check for the error. If error is not equal to nil, fmt.println unable to read command. And if we are properly able to read command, the next step is to trim the \n from this command. So I'm going to use strings.trim suffix user command raw, then I'm going to remove \n, and then I'm going to store it in user command variable. So now I have the user command. Since this user command is of the form like this, for example cd space, what's the issue here? Okay, cd space and then for example move up or down. Let's say we want to move back, which is cd space double dot. So this command helps us in moving one step up in the hierarchy. We need to split this into this thing and this thing. So the first thing would be the command and the second thing would be the directory that we want to move. Let's call it strings since it is in the form of string. So I'm going to call strings.trim, no, not split. So I'm going to split this user command on the basis of space. So what this function will do is that it will return an array and it will divide this string based on the separator. So in our case, the first element should be the command that we want to use, or the string, and the second element should be the separator. So in this case, our separator is space, so it will divide this string into an array of strings, and these array will contain two elements. The first element would be cd and the second element would be double dot. So it would be something like this: cd, and then the second element would be double dot. And then I'm going to store this as user command array. Once we have that, so the first element is cd and this is the directory that we want to move. So I'm going to call directory to move equals, and then I'm going to use this array and the first element of this array. So I'm going to store this element in this variable, and next step is simply to move this directory. But one thing we need to keep in mind, that we need to check if this directory exists or not. For example, if the reader just input cd and there is no second element, we cannot proceed further. So we need to check if the length of this array is more than 1. So I'm going to check if length of user command array is greater than 1, then I'm going to cut this and put it here so it doesn't cause an out of index error. Once we have this directory, the next step is simply to change the directory or move the directory. So in order to move the directory, we have to use os.change directory method and then the directory that we want to move. So this os.change directory function changes current location of the program. So, and this, if it cannot do it, it returns an error. Then let's put a check for an error. If an error is not equal to nil, we can say that unable to change directory. Alright, let's move here. And then what we want to do next is to get the present working directory again, to know that this directory and this directory are different. So I'm going to get the present working directory again by using os.getWorkingDirectory function. So this is our updated or new present working directory. And then what we want to do is we want to send this present working directory back to the hacker, so the hacker knows that our command has worked properly. So let's use the connection dot write byte, and then I'm going to send this present working directory. But note that this present working directory must also contain a \n character, so we can read it properly on our victim. And then the number of bytes and error, and then we can print the statement that press pwd return to the user hacker, and then the number of bytes, so bytes. Okay, so now we have everything set up. We are changing the directory, getting the user input, changing the directory according to the user input, and then we are getting the present working directory again and then sending this back to the hacker. So let's proceed further in next lecture. I'm going to read the command results that I got from our victim machine. Let's start with using connection reader to read the string \n. Okay, and then we have to store this in some variable. I'm going to create a new variable called new present working directory, and I'm going to store this in this variable. Once we have that, we can simply print out the results. So fmt.println working directory changed to new present working directory. Okay, so now we have our program as complete. Let's start it. Go run main.go. So first I'm going to start my server, and then I'm going to the Windows machine, and then I'm going to run the same program here. So go back to the Linux machine. As you can see that we have got a connection. Now it says execute command. Okay, so I did not put the, if I go to the main file, I did not write any statement for this option, so it's not showing any option here. But if I press 2, it will go to this statement. So I'm going to press 2 here. You can see that it says navigating file system on the victim. So let's say we want to move back one command. So if I write cd space ... and I want to move to this source directory, currently I am in the victim final version. So if I press enter, you can see that the command was changed, and it says that working directory changed to C users test go source. So now my present working directory is source. If I go to the execute command and I try to find the present working directory by using pwd, you can see that I get the path as C test go source. So that's how you can navigate through the working directories or file systems. In next lecture, I will try to create a more robust program, and then we will iterate again and again to change the working directories continuously, so we don't have to run this program again and again to change our directory. So let's see you next lecture. Okay, welcome back. In this lecture, we are going to create an iterative loop which will help us in running our commands continuously, and we don't have to go back to main menu again and again, because our current version of program just takes in command and returns the results and then goes back to the main program. So what we want to do is we want to avoid going back into the main loop. So we will add some modifications in our existing program and try to make it more continuous. So the first thing we need to do is we will try to create a loop. We will use the same logic that we used in our previous version for command execution. So we will create a loop control, and then we will try to iterate over this loop control and modify if our stop condition is met. So let's say let's create a new variable called loop control equals to true. Okay, once we have this, our next step would be this one, that before we get our input from the user, we will print out our initial working directory, and then we want to repeat the same process from here till end again and again till a user says that stop execution. We will start our loop here. So I'm going to call for loop control, and then I'm going to start my loop here, and then before return statement I'm going to finish my loop here. So every process that I was doing, that for example reading command, sending to the victim machine, running on the victim machine and getting back the results, everything should be inside this loop, so we can repeat this process over and over again. So, and one more thing we need to change here, we need to set the initial present working directory, which is this one, to the new working directory, which is this one, at the end of the loop, so we get the modified working directory. Okay, so our server side is completed. In next lecture we will focus on our before moving over to our victim machine, let's first write our exit condition here. So let's say we want to say that if we type stop as a user command, we must stop this execution of this loop again and again, and then we move out of this loop. So once we have written our data, our user command to the victim machine and indicating the victim machine that this is our command, we can write the loop exit statement here. So the exit statement would be if user command draw equals what's the issue here? Nothing. So if user command draw equals and then we say if it stop \n, we have to stop the execution of our loop. So to do this, we will set the loop controls to false and then simply break the loop. So this is our exit condition. So in this line we indicate the victim, we send this victim command to the victim machine, telling the victim machine that it also should stop execution, and here we set this stop condition so that we get out of this loop safely. So that's how you define an exit condition. In next lecture we'll focus on victim machine. Okay, so in this lecture we are going to define the looping condition on our victim side. So the first thing we need to do is we need to create the loop variable. I'm going to call it loop control, and then I'm going to set it to true. Once we have that, we need to define where should we start our loop. So as you already know that in our server side we started loop when we before taking our user input. Similarly, we want to do it here where we get the input from the victim side, so which would be here. So in this statement we are receiving data from our command from our server or hacker. So what we want to do, we want to create a loop here for loop control, and then we can end the loop here at the end of this program. Okay, so now we have everything set up. Now the only thing we need to do is we need to set up the exit condition. So what we can do is we can set the exit condition here. So we can say if user command equals stop \n, we can say that break the loop here, but we first need to set the loop controls to false, and then we can break the loop here. So now we have everything set up according to this scenario. So the next step is to run this program. Okay, welcome back everyone. In this lecture we are going to run our program. So what we will try to do is we will try to send commands continuously over to the victim machine, and then we will try to get back the results or file navigation back to the main server or hacker. So let's start it. I'm going to first start my server or hacker machine, and then going to the victim machine, which is Windows, and then I'm going to run my program here. Let's go back to the hacker machine again, and now you can see that I've got a proper connection back from the victim machine. So I'm going to select the option number 2, which is move in file system. So as you can see that we are currently at C users test go source and then victim final version. Let's say now if we want to go to the source folder, I can write cd space .. If you can, now you can see that my present working directory is gone one step up, which is to source. And then for example, if I want to go again to go folder, so I can write cd .. You can see that now I'm going to the go folder. Now let's say if I want to go back to the source folder, I can write cd space src source. Now you can see that I am now into the source folder. And now you can see that we are properly navigating through the file system. And if we want to stop the execution, I can just write stop here and press enter. You can see that I go back to the main menu. And now if I want to go to the command or execute command menu, press 1. And let's say if I want to check out the present working directory, you can see that now I am in the source folder. If I want to list the files, you can see that I have different files here. Okay, so that's how you navigate through the file system. See you in next lecture. Okay, so now we know how to run commands on our systems and also how to move or navigate the file systems. In this lecture, we are going to learn how to upload files to our victim machines. This procedure or this functionality is very important for hackers because this can allow you to upload different files or custom built viruses onto your victim machine and then run these viruses using these tools that you have already developed in your previous lectures. So what we are going to do is trying to upload our files or viruses to victim through this connection that we have already created. So there are a few steps that you need to understand that determines how the files are uploaded to the victim machine. So the first step is the hacker. For example, if you have a virus that is on your own Linux machine and you want to send it to the victim machine, the first step is that you have to read this file from your own system, from your Linux system into your program. So our first step would be to just read the file or read the file contents into your program. The second step is to establish a connection with the victim. We have already done this process, so we can skip this process. The third step is to use this connection that we have developed in step 2 to transfer files or bytes or file contents, whatever it is, to the victim machine. The next step is to write a victim program that will receive these file contents and then it will try to work with these file contents. And the last step is once the victim has this file content or bytes that it receives on its own computer, the victim has to create a new file on the victim machine, and then the victim program has to sort of copy these file contents onto its own system. So we first read the file from our Linux machine and then send it over to the victim machine, and then the victim machine reads these contents from this connection and then copies this connection to the file that it creates on the victim machine. And then once the victim has created the file and copied all the file contents onto its local machine, the victim can acknowledge back to the server that it has completed executing this procedure or finished writing the files or downloading the files to the victim machine. So that's the whole process that you need to keep in mind. In next lecture we will follow this process. Now our goal is to transfer files or viruses to our victim machine. I have chosen a random file, which is this wallpaper I downloaded from the internet. It's called file.jpg. But this file is just an example. This file could be anything, virus, script, whatever you want. So I am working with this wallpaper as an example. What I want to do is I want to transfer this file from our hacker, which is this machine, to our victim, which is our Windows machine. Let's start working with it. Okay, the first thing we need to do is we need to create a package. First I'm going to print out this option statement in main menu so we know that we have an option available. The next step is to create a package. I'm going to create a package in the core directory and I'm going to call it upload file, or just upload is fine. And then I'm going to create another file, let's call it upload as well. And then I'm going to develop a function called upload file to victim. So what this function is going to do is that it's going to transfer our virus files to the victim machine. So the first thing it needs is a connection which would be of the type net.com, and then it's going to return an error. return. So now you have a dummy functional available, and then I'm going to the main file, and then I'm going to create a new case called, let's remove this for a moment. So it's called case 3, and then I'm going to print out a message that we are uploading file to the victim. So now I'm going to call this function, which is upload file to victim. So let's say upload file to victim, and then I'm going to send connection object, going to receive back an error, and then simply I'm going to display the error. So now, as you can see, we have a pattern which is being followed in all the examples. I have developed this pattern so it's easier to understand how you are working in our program. Once we have developed this, let's go to the main to the upload file function. Here our goal is to upload file to the victim machine, but the first step is to read the file, this file, into our program. So the first thing we need to do is we need to write our file name. So file name equals to, and it would be called file.jpg. Okay, once we have that, I need to develop a program which will check, I need to develop a function which will check if the file exists or not. So let's create a function. I'm going to call it check existence, and then it's going to take a file name, and then it's going to return, oops, it would be of type string, and then it is going to return a bool which would indicate if the file exists or not. Okay, let's start checking for file existence. So we can do this by using os.stat function. So if error os.stat, and then the file name error, and then we can check for error if error is not equal to nil. So if error is not nil, we can go into the function and check if os dot is not exist error. So error, so we can check if the file exists or not. So if it's not existing, we can say return false, and if the file exists, we can say return true. So this is how you can check for file existence. The next step is to use this function to check for existence here. So I'm going to create a new let's say check existence, and then I'm going to give the file name, and then I'm going to store it in a variable called file exists. So this checks for file existence. If it's true, we can simply print it, println file exists. So since our file is present, I'm going to run this and check if it works properly or not. So go run main.go upload file, let's see here. Oh, okay, sorry, let's remove this and run this again. Okay, so now it's waiting for the connection, but the idea is that, where is it? Okay, so the idea is that if the file exists, it will return true, and we will simply print out existence or non-existence here. In next lecture we will proceed further. Okay, so now we have checked if the file exists or not. Our next step is to handle if the file does not exist. So we can say that if file exists equals to false, which means that file does not exist. We can create a new error. I'm going to call it error equals to errors dot new, and then I'm going to give my custom string, which is file does not found, and then I'm going to return this error. If everything is perfect, we proceed further. Okay, our next step would be to read the file contents. We should read bytes of this file into our program. Let's create a new function which will read the file contents. So I'm going to call this function as read contents or read file contents. So this is going to receive a file name which would be of type string. And then it's going to return two variables. The first would be an array of byte which would contain all the file contents here, and then it will return an error if there is some problem. So now we have a function, then let's call it okay, let's leave it here and we'll do this later. If the file exists, we can call this function here, read file contents, and then we can give the file name. Let's move over here. Our next step here is to open this file in our program, so we can use this by using os.open function, which will open this file, which is file.jpg. os.open, and then we need to provide the file name, which would be this, and then we will store the file object and error here. So we can say if error is not equal to nil, empty.println unable to open file, and then we are simply going to return nil bytes and then the error, which is the actual error. So once we have a proper functioning file object, we can use this file object to read the file. Before we proceed further, let's just defer this statement, file.close, so we get a proper closure for this file object. Okay, the next thing we need to do is we need to check out what's the size of the file and what is the name of the file. So we can do this by using file.stat, and this will return the file stat. So if you check the documentation, it says that it returns file object and error. So file object, or we can just call it stats, and then error. Now we have stats. What we want to do is we want to find out the size of this file in bytes. So we can use this by calling this object stats and then the size, and this will return an int64 number, which would be the number of bytes this file contains. So I'm going to call it file size equals to stats. So now we have a file size here. The next step is to simply print out this file size, so we know how big is the file. The file contains file size bytes. This is just for our understanding. Okay, so the next step is to create a buffer. So I will do this in next lecture. Okay, so now we know how to get the file size and file information. The next step is to create a buffer and then read these file contents into our buffer. So a buffer is just a collection of bytes that are stored in memory. So what we can do is, in order to create a buffer, we need to do bytes is equal to make, and then what type of it should be an array, and then the size, file size. So what this call essentially does is that it creates a file size buffer. So it creates a buffer which contains an array of bytes, and it has a size equal to the size of the file. So the next thing we want to do is we want to read the file contents into this buffer. At the moment this buffer is empty, but our next step would be to read the file contents. So we can say buffer input output dot new reader, and then we are going to give the reader, which is the file object. So this file object is an input output reader, so we can give it here. So the next step is to store this in a buffer. So I'm going to call this as a buffer. And then once we have this, we can read this buffer using buffer dot read. Oops. Read, and then we have to provide bytes. So what this function will essentially do is that it will read the bytes that are of the file into this buffer. So, and then we can check if there is an error reading or not. Then simply, if everything goes well, we can return these bytes and the error. So now everything is almost complete. So now we have completely read the file. The next step is to send this file over to the victim machine, which we will do in next lecture. Okay, so now we know how to read the file contents. The next thing we need to do is we need to set these file contents into a variable. So I'm going to call this variable as content, and then I'm going to write to read it as an error. Okay. So now we have all the bytes stored in this variable called content. The next step is what we want to do is to find out the length. So we can simply use the length function and then give out the content type, which is simply an array of bytes. So it is going to return the file size. So now we have three elements: the file content, the file size, and the file name. So what we want to do is we want to send all these three elements to our victim machine. But before sending them, we have to put these elements in a struct. So I'm going to create a new struct here. So let's call it type, and then I'm going to call this as file struct since I'm trying to send a file. So there are three things in this file struct: file name, which would be of type string, then file size, which would be of type int, and the third thing is file content, and it would be of type byte array. We have a file struct here. The next thing we need to do is we need to set these values, and then we will send this over to the victim machine. So we have now everything complete, so we just need to set the values. But before setting the values, we should first create this struct. I'm going to call this as fs file struct, and then I'm going to give this as a reference to this file struct. So we have three elements. The file name would be file name, which is it this one. Then the file size would be this one, and then file content would be this content. So now we have a file structure as a struct. So now what we have to do is we need to encode this struct using the gob encoder, and then we will send this to our victim machine. So what we can do is we can create a gob encoder dot new encoder, and then we need to set the connection. It's going to return an encoder, and then simply we can use this encoder to encode encoder dot encode, and then we can give the struct, which is file struct. It's going to return an error, and let's handle the error. If error is not equal to nil, we can simply print out that error encoding, and then simply return here. Okay, so the next step would be to check if the file has written properly or not. So we can do it here, but before checking has been written properly or not, since we have sent the file to the victim machine, next step we will move to the victim machine and start reading this file and pasting it into the victim machine, and then we will know if we have file written successfully or not. So in next lecture we will move over to the Windows machine. Okay, so now we have come over to our Windows machine. Here our goal is to get the data from connection that we are sending and then save this data onto our local disk. So before doing that, let's just create a new case, and user input equals to 3 fmt.println, and then this would be download file. Since we are uploading file from our server machine, here we will download it. So download file from server or hacker, whatever it is. Downloading. Okay, so our next step is to create a package here. So I'm going to move over to this core and create a new package. Let's call it download, and then I'm going to create the same file called download. So, and create a new function called read file contents. It's going to receive a connection of type net.con, and it's going to return an error. Okay, so we have this. I'm going to call it, and then I'm going to move over to the main function and call this function. So it's called download.read file contents connection. So I'm moving forward fastly because these steps are same in previous lecture, so I don't want to waste times on these. And display error. So now we have everything set up here. So in next lecture we will start developing this function. Okay, so let's start developing this function. We are going to receive data from our hacker machine. So to do this, we have to write decoder equals to gob.new decoder, and then we have to provide connection. So now since we have provided connection and we want to use this variable to store contents, but first we need to create the same file struct that we created in our other lecture. So what I'm going to do is I'm going to the Linux machine, and I'm just going to copy this struct so I don't have to write again. Copy, and then I'm going to the Windows machine and I'm going to paste it here. So now we have a struct. The next thing I need to do is I need to create an empty struct here. So I'm going to write fs equals to end file struct. So now I have an empty struct here. Next step is to use this decoder to read data into this struct. So what I can do is I can call decoder.decode, and then I have to provide the file struct, which is the empty file struct. Then error if there is some error. So this will help us in decoding all the file contents into these fields or objects. So once we have this, the next step is to create an empty file on the system and copy this file content into this empty file that we will create. So to do this, we can use os.create method, which will create an empty file depending on the name of the file. So fs.filename. So we provide the file name and it will create an empty file on our system. The next step is to check if the file has been created properly or not. So it's going to return an error and then a file object. So let's check for the error condition. If error is not equal to nil, fmt.println, and then we can say that unable to create file. Okay, if the file is created successfully, our next goal would be to use this file object to write to this file. So before we do this, we can use defer file.close to make sure that the file is closed properly at the end. And then we have to simply write out this file.content, this thing. So I can use file.write method, and then I can write fs.fileContent. This will return number of bytes written and error. So, and then I can print if error is not equal to nil, we can print out that let's print ln unable to write files. Else t.println, you can say that number of bytes written, and then we can say n bytes. Okay, once we have this file written, our next step would be to check if the file has been written properly or not. So we can use the same file exists function that we used previously. So let's okay, so before going that, let's create a variable called status. So this will tell us if the file has been written properly or not. So now here I will use same check file existence method that we developed in our server program. So I'm going to the Kali machine, and then I'm simply going to copy this function, and then I'm going to the Windows machine, and I'm going to paste it here. So check existence, so I can say that if check existence and then the file name exists, what we can do is we can say that status equals to successfully written file, or else if we are unable to write this file properly, we can say that status equals to unable to write file to the victim, and then we can simply send this status to our hacker or server. So we can use the connection.write object, connection.write, to send this status. And before sending this status, we will append \n. It should be of type byte. Oops. So I added \n so that it's we can read it properly on our victim machine, on our hacker machine. So now everything is complete here. In next lecture we will just read the status on our hacker machine. Then that's it. Okay, so the last thing we need to do is we need to store the status that we sent from the victim machine. So to do this, we can create a new reader using buffer input output, new reader, and then connection. And then we can use this reader, reader.read string, then byte, status, error. And then we can simply print out the status. So now we have everything complete. We are reading file from our local machine, and then we are setting the file into a struct, and then we are sending this struct to our victim machine. in victim machine, what we are doing is we are decoding the file struct, setting the values of these struct, and then we are writing this struct into a new file which we are creating here. And once this file is written properly, we are checking the status. If the status of the file is proper, which means that the file has been successfully written, we send this status back to the hacker machine. If I come here, and on the hacker machine we are simply printing out the status. So this is our back and forth communication. So in next lecture we will run this program. Okay, so let's start the program and try to send this file over to the victim machine. So let's start with go run main.go and then go over to the Windows machine and run the same program here. Okay, you can see that there is no file here with the name file.jpg. So if I try to run it, go run main.go and then go back to the server machine, it will take some time to establish the connection. Okay, so the now connection has been established properly. Our next step is to upload this file, which is file.jpg. So since I have hard coded the file name, I don't have to give input, but you can modify this program. So let's press 3 and you can see that there is a message called the file contains 42421 bytes and successfully written. So if I go to the Windows machine, and now you can see that file.jpg has appeared. If I go to the folder, you can see that I have this file, and if I double click it, you can see that I get the proper working file here. So in this way you can send the files to your victim machine and then use these files to, for example, run viruses or something. So that's how you send data to the victim machine. So now you are on the victim side. Here our goal is to upload file to the hacker. So we will create a package and then we will call this package as upload. And then let's create a file name upload. And here we will create a function called upload to hacker, and it will take a connection on, and then it's going to return an error. And let's go to the main function, and here we will write our new case user input equals to 4 println uploading file to the hacker, and then here we will call this function which is upload to hacker connection error and then display error. So now we have everything set up. In next lecture we will develop this upload to hacker function. Okay, so in this lecture try to develop this functionality which is upload to hacker. So what we want to do is we want to get a list of files from here in the Windows machine, then we want to send this list of files to our hacker machine. The hacker will then specify which files it wants to download or which file, and then we can come here and then download read the file contents in victim program and then send these content to our hacker machine, and then hacker can download it. So let's move step by step. So the first step is to get a list of direct files in our present working directory. So our present working directory is this one, which is victim final version. So what we want to do is we want to get a list of files present in this one. So it has 3 files: core, download.jpg and main.go. So we can use ioutl.read directory function. So this function returns an array of file objects present in this directory. So it will return three file objects. So 0 will be pointing to core, 1 will be pointing to download.jpg, and the other will be pointing to main.go. In order to get the list of contents in the present directory, you can use the dot as a directory name. So dot represents the present working directory, and you don't have to specify any hardcore value for it. And then it will return an array of file objects. So I am going to call it files array, and then it is going to return an error. So at the moment I'm just going to ignore any errors. I don't have to write handling statements, but I will assume that everything works perfectly. But you can put these error checkings as well in order to make your program more safe and reliable. So when we have file array object, the next step is to iterate over this files array object. So this files array contains an array of file objects pointing to these three things. So let's use a for loop. So for index and then file object equals to range and then files array. So we will iterate over each file object successively. So the next thing we want to do is, at the moment we are only interested in files, we are not interested in directories. So we can put a check here that we only want to save files or file names. So to do this we can use file.mode operator. So file.mode, so this will return an file mode object. So file.mode, and this will return an object. Okay, and then we can use this mode object to determine if it's a directory or a file. So what we want to do is we want to put an if statement. So if mode dot, so you can see there are various suggestions here. So first one is regular and is directory, and it returns a type of bool. So it means that if the current file object is pointing to a file which is a regular file, then it will return true, and if it's pointing to a directory, then this function will return true. So since we are only interested in files, we can say is regular. And once we have that, what we need to do is we need to store the file names in something. So let's create an array. So I'm going to call it files list, or just files is okay, and it's going to be an array of type string. The next we want to do is we want to store file names in this files array. So to do this you can use append operator. So append operator appends this files, and then what you want to append. Since we want to append the file name, we can use file.name, and this will return and this will append the files to this files array. So now we have everything set up. I am just going to print \t, and then I'm going to call it file. Let's call it file name, file.name. So we also print the statement. Let's just print the index as well. So let's call it here index, and then the file name, let's call it \t. Okay, so everything is perfect now. So now we have a list of files. In next lecture we will send this list of files to our hacker machine. Okay, so our next step is to send this list of files to our hacker machine. To do this we have to create a file struct. So I'm going to call it type, and then let's call it files list, and it would be of type struct, and then it will contain files and would be of type string array. This struct will simply be used to send a list of files to our hacker machine. So let's go here and create an empty struct. I'm going to call it file struct. Okay, let's call it files list. and then we are going to create an empty files list. Okay, so what I did is created a files list object, and then I set out this files string array to this files, which is name of files present in the present working directory. And then the next step is to send to our hacking. So to do this, we can use gob.newEncoder, and then we have to provide connection. And then let's store it in an encoder, and then we can use this encoder dot encode, and then we have to provide the files list and this is going to return an error. So what we are essentially doing is we are creating the file structure and then storing the list of files in this object, and then sending this object to the hacker machine. In next lecture we will store this in we will read this from the hacker machine and try to work with it. Okay, so now we move over to our hacker machine and we will try to develop this download from victim function. So the first thing we need to do is we need to read the files or list of files that we are receiving from our victim. So to do this, we first need to create a struct. So let's go to the victim machine for a moment, and I'm going to copy this, and then I'm going to move over to my hacker machine, and I'm just going to print it here. So now we have a file struct. The next thing I need to do is I need to fill this file struct, but before doing that I'm going to create an empty struct which should be called file struct equals to and file list, and then at the moment we are going to create an empty struct because we need to fill it, and then we need to define the connection decoder. So I'm going to create a gob decoder, so gob.newDecoder, and then I'm going to provide the connection as the writer. Once we have that, I'm going to use this decoder to decode this file struct, and then it's going to return an error. Okay, now we have successfully decoded this object. The next thing we need to do is we need to simply print out. So we can say for index and then file name equals to range, and then we are going to use this file struct dot files. So we are going to iterate over this array, and then we are simply going to print out what array it is. So fmt.println, let's leave it \t, and then I'm going to call this index \t, and then I'm going to call it file name. So I'm simply printing out name of files on the screen. So the next thing I need to do is I need to ask the user to select one of the files. To do this, let's do it in next lecture. Okay, so welcome back. In this lecture we are going to ask the user to select the files. So now we have a list of files here and we have already printed them. Now here we will ask the user to enter the file name. So fmt.print, and then we will ask the user to enter or select file, and then I'm going to create a new reader which should be of type buffer input output dot new reader, and then we are going to take the user input. So I'm going to use os.stdin, which is the standard input. The next step is to read the user input, so I'm going to call it user input raw equals to reader dot read string, then backslash n, then it's going to return an error as well. Once I have this user input, what I can do is that, okay, so the program I want to develop is like this. So over here we are printing the file index and then the file name. Say it would be something like this, for example 0 and then let's say file.jpg, and then 1, and then let's say whatever the file is, let's say main.go. So we have two files. What I want to do is I want to select these files. So there are two methods. Either I can entirely write the file name, which would be file.jpg, or main.go. But the problem here with this approach is that it can, for example, if you type a wrong spelling or something, and file names are usually very long, so this can cause a lot of problem and it's very inconvenient to write every name. So what I want to do is I want to select the files based on their indexes. So I will ask the user to provide me an index, for example 0, 1, 2 or whatever, and then the user will, and once I have this, what I can do is I can simply select the file name by its respective index. Here I can enter either 0 or 1. Once I have this, I can work with this to convert this into the file names. So let's start with it. And so we have already read string. So the next thing is to remove the backslash n character from this user input. So user input equals to strings dot trim suffix and then user input raw and then backslash n. So this will remove the backslash n or new line character from our user input. The next thing is to use this to access our files array. Okay, once we have the user input, our next goal would be to convert this into a string. So we can use this by using strconvert library. So I'm going to use strconvert.atoi. So what this function does is that it takes a string and it returns the number which the strings represent. For example, if the string has number 1, the output would be of number 1 of integer. So since our user is going to input here, our next goal is to convert the string input into an integer input. So I'm going to enter here, which would be user input, and then this will represent the file index. Okay, once we have successfully converted it, okay, so our next step is to use this index, convert this index into a file name. So we can use file index to access the file name. So to do this, what we have to do is we can call, what's the name of the struct? File struct. So we can say file struct dot files, and then we can say file index. Underscore index. So now in this way we can access the file name, and then we can store it in a variable called file name. Now we have a proper file name. The next thing we need to do is we need to send this file name to our victim machine. So I can say connection dot write byte, and then I can say file name, and then I have to append backslash n character at the end so I can read it properly. So, and then I can say number of bytes error equals to, then just print out the statement that file name sent, and then the number of bytes. So now we have sent the file name back to the victim machine. The next step would be for victim machine to read the file name from here and then select the file name from the system and read the contents. our goal would be to read the file name. So to do this, what we can do is I can say let's create a reader. So let me see, do we have a reader here? No. Okay, so reader equals to buffer input output dot new reader and then connection, and then simply reader dot read string backslash n as the byte, and then file name to download, and then error. So now we have a file name. The next step I need to do is I need to get rid of this backslash n from here. Let's call it raw here so we can distinguish properly. File name to download equals strings dot trim suffix, oops, then file name to download raw, and then we have to remove backslash n. Okay, so now we have a file name that we can use to read the files. The next step would be to get the file contents. So we can use the same function, which is, if you go over here, upload. Okay, so it's not here, but we can use the, if we go to the hacker machine, and then upload, I can use the same read file contents function to read the file contents on the victim machine as well. So I'm just going to copy this function as it is, then I'm going again to my Windows PC, then I'm going to paste this function here. I can simply use this function, which is read file contents, and it requires file name to download, and then it return contents and error. So in this way we can read the file contents here. The next step is to set these file contents in a struct and then send the struct to our hacker machine. So to do this, we first have to create a struct. So I'm going to create a struct named data, so let's copy it. Okay, paste it. So I have a data struct which contains file name, file size, and file content. So we have all these things, and I need to send these files to our hacker machine. So I'm first going to create an empty struct and set the fields here. Let's call it. So I'm going to call this struct as fs and data, and it will contain these fields. So the file name would be, this is file name to download. File size would be length of this contents, which is the number of bytes in the file, and then the file content would be simply contents. So now we have a struct. The next thing we need to do is we need to encode this struct and send this to the hacker machine. So I'm going to use the gob encoder. Encoder equals to gob.new encoder connection, and then encoder.encode, and then I'm going to give the file struct. Error equals to this. Okay, so now we have everything set up, storing the file contents here, and then we are sending these file contents back to our hacker machine. So in next lecture we will read this on our hacker machine. Okay, so our next step here would be to get the file content that we sent from our victim machine. So I'm going to create a decoder equals to gob.decoder, then using connection, and then I'm going to use this decoder dot decode, and then I'm going to decode the message that we have files that we sent from our victim machine. But before decoding it, I first need to create an empty struct here. So we first need to create the similar struct that we created in our victim machine. So I'm going to copy it and paste it here. So we have a struct which contains file name, file size, and file content. So then what we need to do is we need to read it. Let's create an empty struct here. Let's call it fs and data. So we don't need to fill fields here. And then we need to give the struct here so we can store the values. And there is an error if there is an error. Okay, once we have this struct complete, the next step would be to write the content on our system. So to do this, we first have to create an empty file. So I'm going to use os.create method, and then we need to define the file name. So I'm going to call fs.filename, which would be the file name that we sent from our victim machine. And if there is an error, we can raise an error, and it returns the file object as well. Now the next step would be to use this file object to write the file. So I'm going to call it file.write, and then we need to define the bytes, which would be in this case fs.fileContent. So we need to write this file content into our file. And if we write properly, we can say that n number of bytes and then error. We can say that fmt.println file downloaded successfully, and then we have to specify the file bytes. So I'm going to call it number of bytes. Alright, so now we have everything set up. Next lecture we will try to run this code. Okay, so let's start working with it. Our first goal would be to start the server. So I'm going to call it as go run main.go, and now we have a server running. The next thing we need to go to the victim machine and try to run the same code here. Go run main.go. Now let's go back to our hacker machine again. It will take some time to connect. Okay, so now it has connected properly. Now the option that we are interested is in the option number 4. So if I press 4 and press enter, you can see that I get two options, 0 and 1. 0 represents the download.jpg file, which is not here. So if you select here, you can see that there is just 3. One is core directory, then file, then main.go. And then we can download either download.jpg or main.go. So I don't want to download main.go because it will overwrite this existing main.go. So what I want to do is I want to download the JPEG. So I'm going to press 0 here, so which means that I'm selecting download.jpg. So as you can see that it says file name sent, which is download.jpg with 14 bytes, and then file downloaded successfully, which is 42 kilobytes. If I go here, you can see that I have a download.jpg. If I double click it, you can see that it's the same file here which was on our victim machine. And if I go to the victim machine, and if I open the directory, you can see that I have a download file here, which is the one that we downloaded on our hacker machine. So this is how you can download and upload files. So this is our section is complete. In next lecture we will move forward. Okay, so in previous sections we have defined how to upload or download files from a victim machine. So in this case, in this section, what we are going to do is we are trying to get directory from a victim machine. So what if we want to steal an entire directory and we don't want to write each file name again and again? So we can use this by using a procedure that we will see in this section. So the first thing we need to do is to create a new section. So I'm going to create a user input equals to 5 fmt.println download folder from victim. You will see that there will be different similarities between this and previous section, but there will be a few key differences too. First, add an option here, so it would be upload file, download file, and then another section called download folder, which would be represented by 5 download folder. Now we have everything set up. The next thing we need to do is we need to create a package, and I'm going to call it, I'll just use the same package. I'm going to create a new function here. So this was called download from victim. Now I will create a function called download folder from victim. So there is a key difference here. Connection net.con, and then it will return an error of type error return. So now we have a function available. Let's go to the main file and call this function, which would be download folder from victim, and then we'll provide connection error and then simply display error. Now we have everything set up. In next lecture we will try to build this function. Let's move over to the Windows machine and try to develop this functionality here. So I'm going to define a new user case, which should be user input equals 5, and this would be fmt.println download folder. So this will provide functionality of downloading folder. Now let's go to the core, and in the upload folder go to upload file, and now we will create another function. So this is upload to hacker. I'm going to create another function called upload folder to hacker, and it will receive the same connection and it's going to return the same error. Let's define the names. Let's call it connection and this one as error, and then it's going to return them. Okay, let's go to the main file again, and here we can call this function. I'm going to call it upload folder to hacker, and then it's going to take in connection. It's going to return an error, and then I'm going to display this error. Okay, so now we have our functionality complete here. The next step is to get the list of folders present in this directory. So to do this we can use the same, is it upload? So we can use the same function here. So here in upload to hacker function, what we did was we just read the files, and then we tried to like store the files in array and then try to send this array to our hacker. So what we will do is we will do the same procedure. We will try to get the file list of directories and then send these directories back to the hacker. So in next lecture we will do this. Okay, so in this lecture what we are going to do is that we are going to work with this upload folder to hacker function. So we will try to get a list of folders first. So in this lecture we will try to find out what folders are present in our root directory. So to do this we first need to define our root directory, which would be the present working directory. Okay, the next thing we need to do is we need to define a string which will contain a list of folders. So I'm going to call it variable folders, and it would be of type string. Then we need to read root directory to find which folders are present. So let's clear it. Okay. To do this, what we can do is we can use ioutil.read directory function, and then we need to provide the root directory here, and this will return two things. The first, it will return elements, and then it will return an error. I'm going to ignore error at the moment. Once we have these elements, note that these elements are file objects. So if you go over there, and you can see that it returns a list of file objects, file info objects. So what we can do is we can loop over this elements list and then find out what type of element is it. Is it a file or a directory? We are currently interested in finding out folders, so we can say for index and then file equals to range elements. And then what we want to do is we want to check if the file is a directory or not. So we can do this: if file dot is a directory, we can know that it's a directory. Then we can simply print it, fmt.println index, and then we can print out the file name, file.name, and then we can append this file.name to this folder. So it should be folder, not file. Okay, let's leave it like this. So the name is a little bit confusing, but note that this is a file object, not a file. So, and then I need to append this folder, so I'm going to use append, and then I need to append this in folders, and I need to append file.name to this folder, and then I'm going to store this in the folders. So now what will happen is I will get a list of all the folders in the root directory, which would be core and zip this and all the hidden files. So let's clear it. Okay, so now we have all the folders list available. The next thing we need to do is we need to send it to our victim machine, our hacker machine. In next lecture we will do this. Okay, so our next step would be to send this list of folders onto the hacker machine in a struct object, which is here. So I'm going to use the same object, which is file list. So as you already know that we did kind of a similar procedure here, where we stored the files in this object and then send it to our victim machine, hacker machine. So what I'm going to do is I'm going to copy this here, and note that this creates an struct and set the folders or files to this struct. So I'm going to copy here everything, and now instead of files we will have folders. So now everything else remains the same. Now what you have to do is you need to go to the hacker machine and do the same and get the user to select which folder he wants to download, and then we will send this folder name to our victim machine. Okay, so now we have sent the folders list to our hacker machine. The next step here is to get the list of folders, print them, and then ask the user to enter or select which folders you want to zip. And then what we can do is we can use the same content here that we already know. So first we will create an empty struct, then decode the list, and then print it, then ask the user to select it, and then select based on indexes, and then send this file back to the victim machine. So we are essentially doing the same process. So I'm just going to copy everything from here till the point to which we sent our selected folder to the victim machine, and then I'm going to paste it here. And note that you should change the name of variables here so you don't get confused. So here it should be folder name instead of file name, because now we are sending the folders. Folder name, and then ask the user to select folder instead of selecting file. And once you have it, you can say that folder to download instead of file to download. Similarly, this would be folder. It's folder, not folder. This should be folder to download. This should be folder index, not file index. Folder index. And this should be folder name. Folder name. So now we are essentially, what we are doing is we are getting a list of folders from our victim machine, printing them, asking the user to select them, and then selecting which folder we want to download and sending it to the victim machine. So in next lecture we will proceed further. Okay, let's move over to our Windows machine, and here what we want to do is that we want to get the file names from the server that we are sending, folder name, not file name, and then we want to zip this folder on our local machine here, and then we will download this zipped file to our victim machine, hacker machine. We want to use zip function because it's very hard to get each file individually. So what we want to do is we want to zip this into a single file, and then we get the same or transfer the same file to our hacker machine, and then we can do whatever we want with it. So to do this, let's go to the previous function, which is upload to hacker, and what we want to do is we want to read the folder name. So I'm just going to get the folder name here, copy, paste. So instead of file name to download, it should be folder name to download. It should be folder name. This should be folder name as well. Okay, so now we have a folder name that we want to download. In next lecture we will try to zip this folder onto our local machine. Our goal would be to use this folder to create a zip file. So we will do this whole process in another folder or function, and I'm going to call this function as zip writer. So what this function will do is it will take certain arguments, and then it will write the folder into the local disk, which is here. So it will take two arguments. The first one would be the base folder, and the other one would be the file name or output file name. It would also be of type string, and then that's it. Okay, so what we can do is we can call this folder, this function zip writer here. So I can say zip writer, and then it requires the base folder, which would be this one, folder name to download, and then it requires the file, the name of the zip file. So I want to name the zip file as the same name as this folder, so I'm going to call folder name to download plus, and then I'm going to add .zip into it. So it would be the same name. For example, if it's a core, then this folder name to download would be core, and the zipped file name would be core.zip. So that's it, and then we will proceed into zipping the file. So since we have our base and folder and output file name, what we can do is we can create a new file using this output file name. So I'm going to use os dot create, and then I'm going to use the output file name. So this will create an empty file on the disk, and then it will write contents into it. So it will return an object called output file and error, and then we can check for error. If error is not equal to nil, we can say that fmt.println error. We can simply print the error, and then we proceed further. Our next goal would be to use this out file, but before doing this I need to close this out file so we don't have any problem later on. So now we have successfully handled the closure of this file. Now we need to proceed further. Our next step would be to create a zip writer. So I'm going to create zip.new writer. So what this function will do is that it will create a new writer that can be used to write the zip files. So to do this, it requires an input-output reader. So where do we want our files to be written? So we want to use this output file as an initial writer for this file, and then I'm going to call it zip writer. Okay, our next step would be to add zip files to this zip writer. To do this, I'm going to create a function called add files to zip. So I will create the functionality of this folder later, but I'm just going to show you how this function will work. So it will require three things, sorry. The first one would be zip writer. The second one would be the base folder. So base folder we have already defined. Base folder, and then it is going to require a third element which would be string, and I will explain later what this string represents. And once we have it, we can simply check. We can see if there is an error. If there is not, we can simply error equals to zip writer dot close. Oops, where did I go? Zip writer dot close. So now you want to close this writer properly as well, and if it's not closed properly, if error is not equal to nil, I can simply print out the error. So now our functionality is complete. Our next step, our last step, is just to add files to this zip file that we have already created. In next lecture we will proceed with this. So it requires three inputs. So what we can do is we can define these inputs. So the first one is simply a zip writer. So zip writer, okay, and it would be of type zip dot writer. The second thing is base path, which would be of type string, and the last thing would be base in zip, and this would also be of type string. And then this function proceeds further. Okay, so the first thing we need to do is we need to find out which files are in the base path. So to do this, we can use ioutil.read directory. So what this function will do is it will return all the elements in this base path. So I'm going to give base path here, and then it's going to return the objects. So I'm going to store this in files variable, and then I'm going to check if error is not equal to nil, simply print it error. Okay, once we have this list of files, we can iterate over this. So I can say for, just ignore the index, and file equals to range, and then files. So what we want to do is we want to work with individual file objects in this directory. So let's proceed further. Let's first print it fmt.println, and I'm going to print the name first. So first thing would be base path, and then I'm going to append the file name. So it would be file.name. So this will tell us which file we are working with at the moment. Once we have this, our next step would be to check if the file is not a directory, which means that if it's a file, then what do we do? So we can say if not file dot is directory. So this implies that it's not a directory and it's a file. So the next step would be to read this file. To read this, we can simply use ioutil.read file, and then we need to provide the file name, which would be base path plus file name. So I'm going to use base path plus file.name. So now we are reading the data from this file. So I'm going to store this in a variable called data, and then I'm going to check if there is an error during reading. If error is not equal to nil, fmt.println, and then error. Once we know that there is no error and file has been read properly, we can proceed further. Okay, so our next step would be now to create another zip file which would be embedded in the original file. So to do this, we can use zip writer.create, and then we need to provide the file name, which would be base in zip plus file.name. So this will create the internal file, this will zip the internal files, and then it's going to return a file object which is called f and error. Then we can say if error is not equal to nil, oops, fmt.println error. Okay, and the next step would be to use this file object which is f to write the data to this file. So f dot write, and then we need to provide the data. Error equals to write. Okay, what's the issue here? Assignment mismatch. So it will return the number of bytes as well. So I'm going to ignore the number of bytes. Okay, so if it's a file, we can work like this. If it's a directory, we can go into the else statement. So let's put a condition here, if file dot is directory. The next step would be to create a new base, because we want to do this process recursively. So for example, if the folder that we are working with contains internal folders, we can do this process again and again until we go through each and every file. So to do this, we can create a new base variable, and then this new base would contain our original base path plus our file name. And then we can use this new base as a source for this function again, so we can do recursion here. And then we need to add the \n character as well. fmt.println, and then we can tell which subdirectory we are working with. So I can say adding subdirectory, and then we can provide the name, which would be file.name, and similarly we can say that new base. Okay, and then we can call the same function again here, which would be write zip writer, and then we can provide the new base, and the last thing would be base in zip plus file.name plus backslash n. So now we have everything set up. So now we will go through recursively and create the zip file for each case. So let's go here, and we are calling zip writer here. Okay, so now everything is perfect. In next lecture we will run this program to see if we create zip file successfully or not. Okay, so there was a minor error in our previous program. You need to add this backslash between the path base path name and the next file name. So if you know that this is the base file name, which would be, for example, zip this, and then file.name would be this subdirectory. So you need to add a backslash between these two so you can get a proper path. So now we have developed our program completely to create a zip file. So in this lecture we will try to run this program and see how it works. So I'm going to start the server program, and then I'm going to the Windows machine and going to run the Windows program as well. Now let's go back to our Kali machine. Okay, now you can see that we have different options here. So since we want to create a zip file, I'm going to select 5. Now it gives me various options. So these are the 3 folders available that I can download. The idea is the internal hidden file for this project. Zip this is a folder that I created that I want to download. So I'm going to press 1, and you can see that everything has run perfectly. If I go to the Windows machine, and you can see that I have a file called zipthis.zip. So if I open the folder here, go to victim find conversion, you can see that I have a zip this file. So if I open it, and you can see the subcontents, for example subdirectory download.jpg as well. And let's go back. In this way you can download every folder you want. So let's say if I go back to the Linux machine, let's say I want to download a folder that is not present in this directory but some other directory. So to do this, what I can do is I can move in the file system. So if I press 2, and you can see that I can go back here, file navigation. So I'm going to press cd space dot dot, and then I went back to the source directory. So I'm going to stop my execution here, and then I'm going to execute commands, and then I'm going to press dir. So this will give me list of all the directories in the source folder. So you can see I have a lot of directories here. Let's say I want to download keylogger. So let's go back to download folder again, which is 5. And now you can see I have different options here. Now I have all these options here. So Cosmia client, Golang hacking, etc, etc. Let's say I want to download this which one? Okay, let's say I want to download this keylogger, which is 8. So I'm going to press 8, and you can see that it has run perfectly. If I go to my Windows machine, and if I open the directory, and if I go back to the source folder, you can see I have a new file called keylogger.zip, and then I can download it to my hacker machine. So let's see how we can download it. So let's go back to the Linux machine. Okay, let's say I want to download file 4. You can see that I have, now it's showing me an option keylogger.zip. If I press 0, you can see that it says file downloaded successfully. If I go here and click here, you can see that now I have this keylogger.zip file on my Kali machine, and if I try to extract it here, you can see that I have all the file contents here. So you can see. Okay, so in this lecture we are going to learn or work with Trojans. So Trojans are basically, let's go into the history first and then I will explain what Trojans are and how they are related. So a Trojan is derived from a Greek story of a Trojan horse that led to the fall of city of Troy. So basically it has some history behind it, that there was a horse that was made of wood and it was used as a deception for the attacking army or something like that. I won't go into the exact details of his story, but it was like a front end horse that was actually made of wood, but the enemy thought that it was an actual horse or something like that. And because of this deception, the city of Troy fell to the Greeks, I think. So a Trojan in computing sense is a program or a piece of code that tries to hide its original purpose. So, for example, it tells the user that it intends to do something, and then it tries to do something else. So it basically performs a deception on the user. So most of the time it is embedded into a legitimate software. For example, if you download a program, for example a chat application or something like that, and it's developed by something anonymous user ABC, then most probably there is a high chance that this has some malicious code inside it, and if you try to run it, it will, on the front, it will do everything it intends to do, for example communicate with friends and family, etc. But it could, in the back end, it could steal your data or tries to do some malicious actions on your PC, which is it is not supposed to do. So this is basically what a Trojan is. So conceptually, a Trojan, for example, let's say this whole thing represents a legitimate software or application, and then there is some malicious program or coding which is embedded into it. So what it does is that it performs all the normal activities, and then in addition to these normal activities, it also performs some program that it is not intended or designed to perform, but only the person who built it knows that it performs it, and the user has no idea that something is happening in the background. And this can lead to a lot of security lapses. For example, he could steal your credit card information if you have stored your data on your disk, or in the modern days there was a hack in which there was a legitimate software used, and in the background it was stealing bitcoins from the wallet. So there are certain features that every Trojan must have in order to classify as a pure Trojan. So it has a cover. So if it's just a malicious program, it's called a virus. But if the malicious program also has some real or legitimate ability or feature that it performs, then it can be classified as a Trojan. And it sits silently, so the Trojan must not be able to be detectable. So the user who is running the program shouldn't be able to detect if the program has some malicious purpose or not. And then usually if you know about viruses, what viruses tend to do is they try to replicate all over the system. For example, if there is a virus that is sent to my email and I click it, the virus will immediately replicate itself and try to send itself to all the users that are in my email list or something like that. Or for example, if I have a virus in the USB and I try to plug the USB into some other PC, it will try to infect the PC, and then if a new USB is attached to this PC, the virus will try to get into the USB and try to spread. But Trojans don't do that. Trojans mostly sit silently, and when they are commanded by their hacker, they try to do something malicious, and their main goal is that they hide their identity. So antivirus softwares uh, are very hard to detect these viruses or Trojans, and they are mostly embedded in legitimate files, for example PDF or something like that. So what we are going to do in this section is that we are going to develop a Trojan that will contain an image file at the front. So we will have an image file. When we click the image file, the image will open, but at the same time our eval file or our backdoor that we already developed will run in the background. Okay, so that's it for this lecture. In next lecture we'll start developing this Trojan. Okay, so now we have a Go file and our program complete. So what we want to do next is to somehow ship or package this whole file to our victim, which is our original victim or the victim that we intend to hack, and then trick him into running this application by making him think that it's a legitimate application or something like that. Currently we just have a Go file. We cannot send it to our victim machine and expect him to run it, because he will need to have certain libraries and everything in order to run it. So what we will do is we will try to build this whole main application into some sort of a package that we can then deliver to our victim machine and trick him into running this application without him knowing that it's a backdoor or something. So what our first goal would be to use this main.go to create a single executable that contains all the libraries and each and everything. So this one package can be used to run from our victim machine and then trick him into doing stuff that you want to do. So the first thing we need to do is we need to go into the terminal, and then we need to run a command called go build main.go. So what this command does is that it creates an executable that contains all the dependencies and each and everything into a one file called main executable, and then we can ship this executable to any victim we want and run it from there. So it's not going to be very easy to trick him into running this main.exe file, but we will see later how we can modify this main.exe file and trick him into running or thinking like it's some legitimate application. We will do this later, but for the moment just focus on one thing, that is we want to ship everything into a single file. So when we write go build main.go, it packages everything and dependencies into one executable. So if we click enter, it will take some time to package it. And it's packaging now. It will take some time because we have a lot of dependencies here. So as you can see that the command ran perfectly, and if I go over there and refresh it, you can see that there is a main.exe file. So now if I open this in a folder, you can see that we have a main file which is application, and its size is quite big, which is around 3.7 MB. And if I go to the properties, you can see that it is an executable. So which means that everything we wanted or intended to develop in our program is bundled into one application, which is main. Now we can simply use this main from anywhere and try to run our code. Okay, so now we have an executable that we can run from our Windows machine. In this program, I'm going to try to connect with my victim machine through this executable instead of using Go files. So I'm not going to create Go files for my hacker or server machine, but I'm just going to create my executable just for the victims, because we only want to distribute this to our victims. We have nothing to change or modify in our hacker machine. So I'm going to run my file from here. So I'm trying to write go run main.go, and I press enter. You can see that it's waiting for incoming connection. Now if I go over to my Windows machine, and if I open this folder in Explorer, and you can see that I have an executable called main, and if I double click it, you can see that it says connection established with server. And note that this is displaying a console, and we will see later how to hide this console, but for the moment just notice that we can run this from our console. So if I go to my Linux machine, you can see that I have a proper program running. So I'm going to close it here again, and you can see that I have closed this program here from my Linux machine. And you can see, if you go over to Windows, you can see that the console has disappeared. Now what I want to do next is to copy this main.exe to anywhere on the system and try to run the program again and see how it works or not. So let's go to the Linux machine and start the program again. You can see it's waiting for incoming connection. Now go to Windows, and I'm going to copy it, and I'm going to paste it desktop. Paste. Okay, so now it is pasted on desktop. So if I double click it, you can see that it has again established the connection, and if I go to the Linux machine, you can see that I have a working connection. The next step I want to do is I want to see my present working directory and see if the program works perfectly even if we run it from some other position. So I'm going to execute commands, and then I want to see the present working directory. So I write vwd, and you can see that it's C users test and then desktop, which means that the program is running perfectly and everything is according to what we desired. So in next lecture we'll try to spoof this executable, because if you send this main.exe to a victim machine, there is a high chance that he will not run it because he will know that there is something suspicious about it. In next lecture we will see how we can hide or package this and trick the victims into running this file without them knowing that this file is being run. So I'm going to stop it, and then I'm going to exit the program. In next lecture we'll proceed further. Okay, so there are two ways to run a Go file. The first one is just directly running it using go run command. Go run main.go, and then if you click it, you can see the output. The other way is to build an executable and then running the executable. So to build an executable, the good thing about Go is that if you make an executable, it compiles all the dependency into one executable file, and then you can just port it to other computer and run it directly from there, and you don't need to install Go on that PC. So in order to do that, just write go build main.go. okay, so you see that nothing happens, but if you go to here, you can see that there is a main file here, and if you list it, you can see that there is a one green file, and then there is another this file which is main.go. So this green file is colored in green, which means that it is an executable. So in Linux you can run the executables using ./main. So if you run it like this, you can see that you get the same output. Now the good thing about Go is that you can build executables. Okay, so once you have this executable, you can just run it from here, or you can run it from terminal. Okay, so let's go from here, cd backslash cd go source plus, okay, cd github.com cd forward. Okay, you can see this is the same thing that we already did here. So you can just write go.min and you can see that there's the same output here. Okay, that's it for this lecture. See you in next one. Okay, so in our previous program we created an executable and then used this executable to try to connect with our hacker machine. So but there was a slight problem in our executable that we created. You see that whenever we double clicked on executable, there was a console on the screen which showed everything that was happening on the victim machine. This is not a very good hacking experience, because if you want to do hacking, you don't want the victim to know that you are hacking his machine. So if you run the program as it is, everything that you do on your victim machine is going to be displayed on his PC, and the user will get the idea that someone is hacking his machine. The next step we want to do is we want to hide this console output that we saw on our screen in our previous lecture. So in this lecture we will try to hide this. So you note that we created an executable using go build function, but there are slight modifications in this build command that we can use to hide this console. So let's say I can write go build, and then we need to provide certain flags which help us in hiding the executable. So the first thing we need to do is you can set -ld flags, and then you need to provide the parameters. So -h equals to Windows GUI. So what this command basically does is it tells the Go compiler to create a Go executable that does not show any console, and then what you can do is you can give another flag or command which is -o, and then you can write whatever name you want to give to your executable. In our previous program, the Go compiler simply took out the main dot. We had a file name called main.go, and it created an executable called main.exe. But if we want to create it with some other name, I'm let's say going to call it image.exe, you can give the output -o, and then you have to give the file name which is main.go. And if you press enter, you will see that it's waiting, and now it has compiled. If you go over there, you can see that there is an image.exe file. And if we try to go to the Linux machine, clear this out, and try to run this program, and you can see it's waiting for incoming connection. Now I'm going to the Windows machine, and I'm going to run this image here. So now you can see that you don't see any output here, but if you go to the task manager, performance processes, and you can see that there will be a process named image, and you can search it somewhere here. You can see here it is. So this image process is running in the background, but it's not showing being shown on the screen. And if you go to the Linux machine, you can see that we have a proper connection. So now we have our goal of hiding we have completed the goal of hiding the console on our victim machine. So now our program is quite stealth, and the user will not be able to see what is happening on the screen or whatever we are doing with in the background. In next lecture we will proceed further. Okay, so now you have created an executable with no console. Our next goal is to make this file more believable to the victim. So what we can do is I'm going to open this in a terminal, in an explorer. Okay, so now let's do it like this. Okay, so now we have an image executable, but it does not have any icon, and it still looks very suspicious. So what I want to do next is to make this more and more believable, so the user will be tricked into running this file. So if I go over here, I have a spoofing.bat file. So I've created this file, and you can use this file, but I will provide the link of this file in the resources. So what this file basically does is that it has two links, URL1 and URL2, and then whenever this file is run, this file will try to download this file from URL1 and run it, and similarly download the file from URL2 and run it. So what will happen is, okay, so what I want to do is I want to download a legitimate file from the internet and show this to user, and then I want to download an evil file and run it in the background. So to download the URL1 or a file that will be shown at the front, I will go to Google, and then I'm going to download any wallpaper. Let's go to images and select any file. You can select any file. Let's say I want to select this file, and then just right click the file and click on copy image address. So this will copy the direct downloadable link for this file. So if I go to the new tab and paste the link here, you can see that the end shows an extension called .jpeg, and if I press enter, you can see that I can directly access the file. So it means that this link is downloadable. So whenever we call this link, this file will be downloaded. So I'm going to copy this link again, and then I'm going to replace this URL1 with this link that I just created or downloaded. So our next step would be to use this URL2 to run our evil file. So our evil file in this case is image.exe, but this image.exe is currently on my local system. So what I want to do next is to upload this to a file hosting website and then download it again. So there are a lot of file hosting websites that provide this functionality for free, file hosting free, and you can see there are a lot of options. I'm just going to use this tiny upload. So it says choose a file. I'm going to select this image here, which is image.exe, and then I press upload. It will take some time to upload. Okay, so now it has uploaded, and I close this, and you can see that I have a download address. So I can use this link to download this file again, and now I will copy this link address. Let's go back to our Goland, and I will replace this link with the current link that I got from here, which is this thing. So now we have a working file. So I'm going to press Ctrl S to save it, and I'm going to my victim machine, and I have this link here, which is a file here, which is called spoofing. With the evil file in the background. So let's go to the Linux machine for the moment, and I'm going to run my program here. Go run main. Now this program is waiting for incoming connection. Let's go to the Windows machine again, and you can see that I will now run this file here. So note that this file does not have any icon or anything, but it's called spoofing. Okay, so now we have a batch file which is executable on Windows, but we will not execute it using batch file, because batch file contains scripts, and Windows by default has blocked execution of scripts on Windows. So batch files do not run very efficiently on Windows because of security upgrades, etc. So what we are going to do is we are going to convert this batch file into another executable, and then we will run this executable. So to do this, go to the Internet Explorer or whatever browser you are using and try to download this application. It is called batch to exe converter, and there are a lot of links. I'm going to use the first one, which is batch to exe converter, and then I'm going to download it from here. I hope this link works. So, okay, let's open it and try to install it, and let's see if there is anything suspicious, because This website's quite suspicious. It looks okay. So let's install it. Okay, so now we have a batch to exe converter, and you can see that it requires a script here. So what I am going to do is I am going to the victim, and I am going to open this in how should I open it? Just edit it. Okay, so it has opened this script in a notepad, so I'm going to copy the whole script, and then I'm going to paste the script here. So I have copied all the contents from here to here. The next thing I need to do is I need to compile, where is it, to build an exe. So what you want to do is you want to create an exe for Windows 10 or Windows 8, whatever our machine is, and then it requires a lot of other features, but we can have an icon. You can see that it does not have any icon at the moment. Our next step would be to build this icon. So I'm going to stop here, and in next lecture we are going to build icons. Okay, so this is the image that we want to download, but this image, what we want to do is we want to show this image as an icon. So currently this image is in JPEG format, and we can't use it as an icon. To use it as an icon, this file must have an extension called ICO or something like that. So what I'm going to do is I'm going to save this image. Let's save it on desktop, and let's call it icon or image dot whatever it is. Save. No, it saves it. It saved the file as a web page, but I want to save it as an image. So let's click it again. No, we can't do it like this. So what I will do is I will take a screenshot. So snipping tool, snipping tool. So let's create a new screenshot of this image, something like that, and then I'm going to save it, and I'm going to save it to my folder which is victim, and let's call it image1, and the file type is PNG or portable network graphic file. The next thing we need to do is we need to convert this PNG file. Let's minimize it for the moment. So this image1 file is currently a PNG file. What we want to do is we want to use an icon image. So there are online converters which can convert PNG to icon. So I'm going to one of the websites, and then I'm going to upload the file here. Final version, and then I'm going to select this file, and then I have to download it. So I have uploaded the file. Do I click here? I don't think so. Okay, so now we have a downloaded file which is the same file, but now its type is, if I click here and go to properties, you will see that it has an extension of ICO. Now this file can be used as an icon. So I'm going to copy this file here, and I'm going to paste this in my folder. So now I have the same file, but this file is not in PNG but in icon form. Now I'm going back to my batch to exe converter, and I'm going to select icon, and then I'm going to my folder and select the same file as an icon. So now we have everything set up. The next thing simply I need to do is I need to build an executable. So I'm going to press an executable, and then I'm going to store it as my image. You can see that it has an extension of exe, but we are not worried about it at the moment. Exe saved. So if you go over here, you can see that we have an image which is an executable, and it has a name myimage, and its icon is the same image that we downloaded. But if you go to properties, you will see that it is an application at the moment. But if I see it as it is, I will see that it's not an executable. It looks like an image, and if I double click it, you will see that I will be able to connect with my hacker. Okay, now you have created an executable with an icon, which is the image that we want to download. So the next step would be to run this. To run this, let's start the Golang and start the server here. And now it's waiting for incoming connection. If I go to the Windows machine and try to run it, you can see that I have the image. Sorry, if I go to the Windows machine, you can see that I have an image here, and it has a connection with the hacker machine. If I go to hacker, you can see that there is the program that communicates with the victim machine. So in this way you can spoof the file into thinking that it is working, it's a legitimate picture file, while in the background it downloads the evil file and starts the evil file. So this is how you can spoof the user or victim into thinking that it is a legitimate picture which can be which he has or the hacker has sent, and then when he runs it, it displays the image, but in the background it runs the evil file as well. Hello, so welcome back. In this lecture, what we are going to do is we are going to use public IP to attack our victim. For example, if our victim is not present in our local network, here you can see that our IP is local IP. So this local IP can only be used if the victim is present in the same local network as yours. But what if you want to attack a victim over the internet? That is, the victim is not present in your LAN. So to achieve this, you need two things. The first thing you need to do is you need to get your public IP. So in your hacker machine, what you need to do is go to your Google page and find out your public IP. So if you just write in Google, for example, what is my public IP or something like that, you will get a 32-bit number which will tell you what your public IP is. And then in your victim program, instead of writing your local IP address, write your public IP address. It will be something like, for example, 89.57.68 whatever 35. It will be something like this. Now replace this server IP with the server public IP, and then once you have completed this step, the next step would be to go to your Kali machine and enable IP forwarding in your router page. So just go to Google. This step is different for every router, so I can't really tell you how to do it, but mostly what you can do is that go to your router page, for example 192.168.0.1, and most cases this is the same, otherwise this home address will be written at the back of your router. Once you have gone to this page, the next thing you need to do is you need to find out port forwarding tab, and once you find out this tab, you have to go there and enter the port that you written. For example, if I go to Windows machine, I'm currently using port 9090, so you have to enable port 9090 port forwarding on this port in your router settings, and once you save it, all the data packets that are coming from external internet onto your local network will be forwarded to your machines automatically. So that's how you can attack victims that are not inside your local network.